Good morning, everyone. Today I'm going to talk about cryptography in ancient and in modern world. But first, what is cryptography in the first place? The definition of this is as follows. Cryptography is the process of converting ordinary plain text into unintelligible text and vice versa. It is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. But, can we really understand it by just the definition alone? Of course not. That's why you should stick till the end of the video to learn more about cryptography. Now let's talk about the origin of cryptography. The earliest known example of cryptography was found in a tomb of an Egyptian noble named Khnumhotep II, who lived approximately 3,900 years ago. The purpose of symbol replacement in the Khnumhotep II inscription was not to conceal information but to enhance its linguistic appeal. The oldest cryptographic technique, the hieroglyph, it is a picture of an object representing a word, syllable, or sound as found in ancient Egyptian and other writing systems. We can see here that the ancient people used to embed pictures of living and non-living things such as the birds and their weapons on the wall or clay tablets so that they can use them to formulate a message, and it's truly remarkable to see. The earliest known cryptography being used to protect sensitive information occurred around 3,500 years ago, when a Mesopotamian scribe employed cryptography to conceal a formula for pottery glaze, which was used on clay tablets, just like the image on the right. And now, what is the importance of cryptography in the ancient world? It is used in protecting important military information. For example, in the Greek city-state of Sparta, messages were encrypted by being written on a parchment laid over a cylinder of a particular size, making the message undecipherable until it was wrapped around a similar cylinder by the recipient. It is called the Citale cipher, just like the image on the right. And now, I'm gonna show you a video on how to do it. In this video, you will see a guy with a glass cylinder wrapping a thin piece of cloth around it in order to create the Citale cipher. Here, you can see the guy writing down the decrypted text he wants the recipient to read. With this, he finally came up with a decrypted text saying, "Help, I am in trouble." As he unwraps the thin cloth, you will see the cipher text with it. Perhaps the most advanced cryptography in the ancient world, the Caesar cipher. It involves shifting the letters of an encrypted message by a certain number of places down the alphabet, as you can see here in the image on the right. But we're gonna talk about it more later on. Now we're all done with the origin and the history of cryptography. The next step is for us to determine the basic things we need to know about cryptography. Cryptography has 4 objectives. 1 is confidentiality, 2 integrity, 3 authenticity, and 4 non-repudiation. Confidentiality. The sender and receiver can be assured that no third party can read the message. That is because they are the only ones who know about the message. Integrity. The sender and receiver can be guaranteed that no third party can make changes in the message. Since they are the only ones who know about the message, they can be 100% sure that nobody else could change the message. Authenticity. The receiver can be sure that the sender sent the message. This is because, again, they are the only ones who know about the message. And also, the receiver is the only one who can decipher the message of the sender. Lastly, non-repudiation. The receiver can prove to any third party that the sender sent the message. The receiver should be the only one who's going to be able to understand the message of the sender. Now, let's look at the basic terms we need to know in cryptography. Encryption, the process of using an algorithm to transform information into a format that cannot be read. Decryption, the process of using another algorithm to transform the encrypted information back into a readable format. These are the commonly used cryptography. First is the pigpen cipher, 2. the shift cipher, 3. the substitution cipher, and 4th, the Vigenère cipher. Pigpen cipher. The cipher is a simple substitution cipher in which each letter of the alphabet in use is assigned a different letter or symbol. Now, here's an example. X marks the spot. But how did we arrive with that answer? We have to look at the key, which is the image on the right. We have to pair the corresponding symbol to the letter just like this letter X. As we can see, the symbol is similar with the key that represents X. That is why we put X. Same thing goes with the letter M. Since the symbol looks similar with the one in the key, which is a box opening on the left with a dot inside, we can clearly see in the key that it represents the letter M. And it's same with everything. We just have to pair the symbol to the corresponding letter to decipher it. Shift cipher. It involves shifting the letters of an encrypted message by a certain number of places down the alphabet, just like the Caesar cipher we talked about earlier. Now, here are examples of shift cipher. The key given is shifted to the left 3 times, which means it has a key equal to 3. In the example, we just have to pair the letter in the ciphertext to the corresponding letter in the alphabet here in the key to get the plain text. Since K is paired with H, we put H. Then H is paired with E, so we put E, and so on and so forth. We get the plain text hello. Same steps with the second example. Substitution cipher. It is very similar with shift cipher, but here, the key is not just shifted. The key could correspond to another letter in random, which makes it even harder to decrypt than shift cipher. Here, we can see that the key is not just shifted and each letter is paired with another in random and no pattern. However, the steps we're going to do is still the same with shift cipher. As we can see in the example, we can pair each letter of the ciphertext to the key, which will give us the plaintext hello and cipher. Lastly, the Vigenère cipher. It is polyalphabetic, which means the letters are not fixed like monoalphabetic. That is when a letter is paired with another, that letter will always correspond with the other. Here, we utilize the use of keyword and key stream. We can see here that the letters are now paired with numbers starting from 0 to 25. Here is the example of Vigenère cipher. The given are the key, which is Venice, and the ciphertext. The first step to do is to pair each letter of the ciphertext to the key Venice. After this, we write down their corresponding numbers shown on the table above. The number for the ciphertext will be put in the EKX. For example, the letter B is paired with 1, so we write 1 on the EKX. Y is paired with 24, so we also write it down, and so on and so forth. Meanwhile, for the key, it will be put in the X key stream. V corresponds to 21, E corresponds to 4, and so on and so forth. We just have to repeat writing Venice until all letters in the ciphertext is paired. The next step is to subtract the EKX to the X key stream. Since the first one we will get a negative answer, we add 26 as the number of letters in the alphabet. But for the rest, it is just subtraction. Simple, right? After this, we can look for the corresponding letters with the computed X to solve the ciphertext. Since the first X is 6, it is paired with the letter G. Second number is 20, which is the letter U, and same goes with the other computed value of X. This will help us in getting the plain text of the cipher, and after a while, we will get the answer, which is guard the palace. Now, was that really hard? Now, I'm going to talk about cryptography in the modern world. We can see here two encryptions, symmetric encryption and asymmetric encryption. Symmetric encryption, aka secret or private key cryptography, uses one key which can be used to encrypt and decrypt data. Asymmetric encryption, in this system, two keys are used, a public key and a private key. The private key is known only by one person who does not want to share this to anyone. The public key, however, is free to be sent to anyone the originator deems to fit. Symmetric encryption is an old technique while asymmetric encryption is relatively new. Asymmetric encryption was introduced to complement the inherent problem of the need to share the key in symmetric encryption model, eliminating the need to share the key by using a pair of public-private keys. And now, here are some examples of cryptography seen in the modern world. The first is cryptocurrency. In the image, that is Bitcoin, one of the most famous cryptocurrency today. Cryptocurrency is a digital or virtual currency that uses cryptography for security. The next one is the binary code. It is based on a binary number system in which there are only two possible states, off and on, usually symbolized by 0 and 1. It is usually used in coding. Cryptography has been with us since the beginning of civilization. The reason for this is because it secures information and communications using a set of rules that allow only those intended to receive information and process it. We can also use cryptography for entertainment. You can also make your own cryptography if you want something to be hidden or you just want to have fun and let your friends and family crack your code. Cryptography is such a wide concept, and it's not just limited to the ones I have presented. Here are some more examples of cryptographies. Thank you for watching, everyone. I hope you like my presentation and I hope you learn a lot from it. It has been a pleasure presenting this. And yeah, Shin Gaite out.